It truly is an honor and a privilege to be here with you today. Before I get going on with my presentation, I wanted to take a brief moment to thank Todd Lewis and all the staff at All Things Open. Time after time, Todd and company deliver an amazing, a great product. Dollar for dollar, this is the most valuable conference that I attend every year. Finally, I just wanted to let you know that this is my first time speaking at an All Things Open event. I certainly hope it is not the last one. A bit of housekeeping. It is certainly my intention to cover the material in the presentation in a way that leaves us with a few minutes for Q&A. If I fall short on that goal, please contact us at info@DataCrunch Lab with any questions, comments, or feedback that you may have, and we will certainly get back to you at our earliest convenience. That said, the reason why you're here. Let's get started with the presentation. I titled this presentation, Open Source Gives You the Edge. And I did it that way for several reasons. I wanted it to be catchy, somewhat enigmatic. I also wanted it to be ambiguous. And I also wanted to hint at what I wanted to cover. The edge that I allude to in the title could be interpreted as an edge in terms of competitive advantage. Open source enables, facilitates, certainly empowers. So in that way, it could definitely give you a competitive advantage. The other take on the word edge refers to the IoT edge, specifically the different pieces that could be leveraged and combined to provide a solution to your customers. In upcoming slides, I will cover a few representative scenarios of cases where bringing computation closer to where the data originates may not be just desirable, it may be necessary. Here's what I will be covering. By presenting a few scenarios, I hope to build a case for edge computing. I will borrow words from the Linux Foundation to frame what is edge computing. We will look at a few well-known software foundations and some of the projects that you may want to look into to support your own projects. I will outline some of the criteria I use to determine which combination of components let me get to 80% of the solution. Finally, time permitting, I'll take a close look at the prototype we developed for the United States Department of the Navy. Well, we have to do this. Things our lawyers make us say. The views expressed on this presentation constitute our best interpretation of the elements outlined. You can read the rest. As I said earlier, my name is Robinson Montalvo. I go by Rob. Fun fact, believe it or not, I did learn how to do sourdough bread last year. If you're looking for a way to build your patience, highly recommended. So here's a little bit about DataCrunch Lab and some of the things we do. Because you're not here for that, I will say that I'm going to move on to the next slide. So this is a picture of a missile frigate of the Italian Navy, specifically the Carlo Bergamini F590. It belongs to the class of European Frame-class frigates. The US Navy recently commissioned Fincantieri, an Italian shipbuilder, to build a few of these for their fleet. This was actually the inspiration of the prototype we did for the Department of the US Navy last year. Some of the critical components on this kind of ship are very well instrumented for the purposes of assessing their health after a certain period of time. There are, as you might imagine, all kinds of sensors connected to the turbines, the compressors, the hull, even the propeller mechanism. The way things work today is that data originating from sensors is collected, in some cases manually, and uploaded onto a system onshore that aggregates and processes the data to extract insights and determine maintenance needs after the ship gets to the shore. In other words, while the ship is actually out on sea, it is generating tons and tons of information. It is monitoring different components, doing all kinds of different things. But the things that could be done to help, like perhaps doing maintenance, like preparing for the eventual replacement of a pump or a bearing or additional maintenance, all those things have to wait until the ship gets to shore. And this, as you might have imagined, has certain implications. At any rate, because of the nature of these assets, we cannot use traditional networking approaches. Wi-Fi won't work. A tethered Ethernet, of course, won't work either. 5G will not be of much use when the vessel is several miles away from shore. I'm sure you get the picture. The most widely means of communication in this situation is satellites, and it is not a feasible means of transferring data for analysis and processing in a public cloud. As you might have guessed, this same sort of challenges will be faced by cruise ships or cargo ships, as the Ever Given. Like in the case of a moving ship, a stationary offshore wind turbine would have similar constraints and would require a similar approach if a condition-based maintenance technology were to be developed for this kind of assets. One could argue that this particular scenario could be addressed by a traditional public cloud data center. There could be a series of advantages in bringing the processing closer to the turbines. This particular picture is intended to represent the use case of a smart city project aimed at helping planning, traffic management, and other objectives. This is one of those where you would want to ask, do we need to count cars? Do we want to double up by attempting to count people in the vehicles? Do we need to tell whether the same vehicle has gone by several times during the day? Certainly, this is an interesting scenario that could surface concerns over privacy. The use behind this particular picture is truly fascinating. Duostech, a company out of Jacksonville, Florida, built a portal aimed at visual inspection of rail cars. And when we say visual inspection, we're talking about real-time visual inspection of rail cars. The company claims that it can provide real-time, detailed 360-degree imaging at speeds of up to 70 miles per hour. In the course of just a few minutes, the system generates terabytes of data. Transferring all the data, storing it, and analyzing this in the public cloud might present quite a few challenges, not to mention the long-term cost of such a proposition. The last picture here shows self-driving vehicle technology. This is one of those cases where latency is critical. The system must make real-time decisions to effectively navigate the environment while meeting all kinds of dynamic conditions. Deer crossing, missing marking, drunk drivers, pedestrians, you get the idea. So having looked at these few cases and scenarios, let's look at what the Linux Foundation refers to as edge computing. So looking at this definition, delivery of computing resources to the extremes of a network with the purpose of improving performance, security, cost, and reliability of applications and services. I recently came across a white paper from the Linux Foundation. The title of the paper is Sharpening the Edge, Overview of the LF Edge Taxonomy and Framework. I particularly like this diagram because it helps visualize edge computing through the continuum of physical infrastructure that comprises the internet, from centralized data centers on the far right to the constrained device edge on the far left. All major open source foundations have projects that are being used in edge computing projects. And we're talking about IoT edge projects. A lot of the projects originated in the industry and have contributions from Red Hat, Bosch, OSIsoft, IBM, and other giants. In the next few slides, I will introduce some of the technologies and projects I looked into and experimented with in some cases, while I was considering ways for us to shortcut the time and effort that it would take to develop the prototype for the Navy that I alluded to earlier. The projects that I looked into came from Apache, the Apache Software Foundation, the Eclipse Software Foundation, and the Linux Foundation. The Apache Foundation has hundreds of open source projects. Some of the projects under the IoT category are portrayed here. Of special note is Apache Kafka. Kafka is a distributed event streaming platform. And Certainly, because of that, it could be considered as foundational technology for bringing data from sensors, IoT sensor nodes. Another component we see here is Apache Camel, which is an open source integration framework based on known enterprise integration patterns. Distributed database, Apache Ignite, is a distributed database for high performance computing within memory speed. And IoT DB is a relatively newcomer. It's a relatively new project. It is an IoT native database with high performance for data management and analysis. It's deployable on the edge and the cloud. This particular project might be of interest to people seeking alternatives to existing time series databases. The last one here on the list, Apache PLC4X, is a universal protocol adapter for industrial IoT. It is a set of libraries for communicating with industrial programmable controllers, or PLCs, using a variety of protocols while using a shared API. That's clearly one of the advantages. So another foundation, the Eclipse Foundation, has 10 regular projects that are shown here on this slide, and 25 others incubating under the Eclipse IoT initiative. Many of these projects are coming from the industrial IoT area. They have that kind of bent and are backed by European giants such as Bosch. Here we see projects that deal with a digital twin or a digital representation of the state of a particular asset. We see projects that deal with communication with the actual device. We see Mosquito, which is a popular MQTT client and server, or can be used for that, and so on and so forth. From the Eclipse Foundation, I particularly liked this project because it allows us to install a single off-the-shelf package and really quickly start using the technologies within it without the time that it takes to manually integrate these. So in a way, you can think of this as being a packaged solution for certain IoT projects. The cloud to edge package inserts an edge node in between the cloud backend and the IoT devices. Now, the IoT devices connect to the edge node, and the edge node connects to the cloud backend. So this particular package consists of 4 projects. Eclipse Hono for device connectivity, Eclipse Ditto, or Ditto, for managing and organizing digital representation of physical objects, aka digital twins, Eclipse Hawkbit, for rolling out and managing software updates to IoT devices, Eclipse IO Fog, for building and running applications at the edge at enterprise scale. Another set of projects from the Linux Foundation include Acraino, the EdgeX Foundry, Eve, Fledge, Home Edge, Open Horizons, State of the Edge, Beetle, and Secure Device on Board. So the Linux Foundation has projects that they usually start at, considered as at-large projects. And these are projects that are in the early stages of being adopted by the foundation or being promoted by the foundation. From there, they move into growth stage. And from the growth stage, they mature into the impact stage, where they're considered to be mature enough and they have met their growth goals and they are actually being adopted by the industry. And there is a significant number of use cases where the technology has already been leveraged by different people or that are being considered for a particular solution. So at the very top, we see Acraino and EdgeX Foundry, and these 2 projects are considered impact stage. So we're moving from the top to the bottom. The projects at the bottom are, in a way, new. They're getting started and they're considered at large. So Beetle and Secure Device on Board are considered at large. Eve, Fledge, Home, Edge, Open Horizon, State of the Edge, these are all considered growth stage. And as I mentioned earlier, Acrano and HX Foundry are considered mature and ready for the real thing. Acrano is a set of open infrastructures and application blueprints for the edge. Fledge came to the Linux Foundation as a contribution from OSI Soft, one of the leaders in SCADA technologies. And Open Horizon was contributed by IBM. And it is a platform for managing the service software lifecycle of containerized workloads and related machine learning assets. Going back to the HX Foundry architecture, this one was one of the projects that I looked at relatively early in my research. Definitely caught my eye for several reasons. It was very modular. It was very easy to understand how things fell in place and how they talk to each other. It was based on microservices architecture, so that led me to believe that expanding in scale would be something that could be done relatively easily by using something like Kubernetes. And the amount of extensibility, looking at the very bottom in terms of support for additional devices outside of what they provided by default as part of the existing project and community. So at any rate, it is highly flexible open source software framework that facilitates interoperability between heterogeneous devices and applications at the IoT edge, along with a consistent foundation for security and manageability, regardless of the use case. What else do I want to say here? Okay, so one of the things that I wanted to do after having looked at all these projects was, okay, so what are the things that really matter to me as I try to shortcut the time that it takes to develop that prototype? How quickly can I get there? And will, in the end, after I develop the prototype, would I have achieved the goals that I intended, that I set out to do? And things that constituted the criteria for evaluation of the different projects was the level of security. As you might have guessed, the Department of Defense is very keen on security. We want to make sure that whatever is being transferred is secure, that it doesn't, it cannot be tampered with, that we can assure that the data came from a reliable source, and that eventually the data would get to us in an integral manner. Clearly, when you're dealing with an asset the size of a Navy ship, we're not looking at 10 sensors, 50 sensors, 100 sensors. You're looking actually at thousands of them. And we needed to develop a platform that would scale, that would handle the volume of data, that would handle the conditions that were thrown on it. Another criteria that I took into account was the extensibility. If I adopt one of the projects, if I decide to use that particular project, will I be able to contribute to it? Will I be able to make changes to it? Will I be able to adapt it to my needs if it came to that? So in other words, I needed to determine, do we have the necessary skills in-house to be able to augment, to be able to extend? Another point of view that I looked at was the community behind the project. Is the community active? Is it responsive? When problems come up, how do they handle that? When people have questions about the technology, are they responsive? Are they there to support the needs of the people that actually rely on the project? Is there a spirit of collaboration behind the project? And these are things that I continue to keep in mind as I evaluated some of these building blocks. Another particular element that I looked at very carefully was what would be the implication if I rely on an existing project from an open source project. How would that impact my intellectual property? Will I be exposing myself? If I touch this code, if I make any modification, if I bring it in-house and I make it a part of my solution, does that mean that I'm going to have to give my IP? Do I have to essentially give up my competitive advantage? That was another criteria that I looked at very carefully. And last but not least, and by the way, this is not an all-inclusive list. I am sure there's many other criteria that you personally might add to this list. But these are the things that I considered very, very closely and looked at very carefully in deciding which elements and which projects to experiment with and which projects to be able to make it a part of my solution. And the other one is deployability. How easy would it be for me to grab their bits and put them together and start an evaluation process? Once I have that in place, how easy is it for me to be able to make an update? How easy would it be for a potential adopter to leverage the technology and bring it up to date? So those are the elements that I looked at very, very carefully. So as I alluded earlier, last year, we won a contract with the Department of the Navy to create an edge analytics node for condition-based maintenance of various systems. We created a digital twin of their propulsion system to include the gas turbine, the compressor, the hull, and even the propeller mechanism. The limitation is sparse communication of ship to shore, as you might remember. So all the data collected cannot be effectively sent to shore to be analyzed there. So with those limitations in mind, we looked at, so what can we do and how with the data that we collect, and what kinds of ways can we contribute to the problem that they were trying to solve. And the problem effectively was one of, so we have all this data, we have the capability of doing very sophisticated analysis to be able to tell which particular systems need attention and how. We have all kinds of different algorithms that we can apply. In fact, we could do all this while the ship is at sea. But the problem was that we couldn't send all that data back to the shore real time, or actually in any other way, to be analyzed for the purpose of scheduling an intervention when the ship got to shore. So again, what ends up happening today is that the Navy collects a lot of different data from different sensors and different components. And if that data could be transferred as it is being collected to the shore, then one can conceive a whole bunch of different algorithms that are operating on that data and keeping an eye on the health of the assets for which these sensors are attached. And as we might remember, having access to that data over satellite is not exactly very feasible. So with that in mind, we created an edge node prototype that ingests data from onboard sensors. In fact, 25 different sensors in this case. We created a dashboard to display the telemetry data for maintainers on board. And the edge analytic node crunches the numbers to assess the state of the decay and percent efficiency instead of sending all the data to shore. In other words, it actually applies a bunch of different algorithms and ML algorithms, crunches the data, and arrives at a an assessment. This is what I am pointing at here at the very bottom, the area that is inside the square. And it crunches the numbers to assess the state of the health of the system. And then we have certain machine learning algorithms that eventually, using a physics-based simulation, data as ground truth, monitors. And this is what we see at the upper right-hand side, where we effectively arrive at a conclusion, at an assessment that says, this is where we are at this time. So with that kind of data, then we can assess, what do we do now? Knowing that the gas turbine is in a state of decay, knowing that the compressor needs attention, knowing that the propeller is getting to the point where it might need an intervention, we can then use that information to provide an assessment. And this is what we see here on this particular screenshot. The elements that we see on this particular slide on the right-hand side is actually a screenshot of the IBM Maximo assets system, asset management system. And what we were proposing was that we have this edge analytics node that crunches all the data, analyzes the data, arrives at an assessment, decides what's the state of health of the particular asset that we're monitoring, and determines that an intervention is needed. It sends a request or provides information through Maximo to indicate an actionable insight. In other words, instead of sending all the data to shore, why not simply send the results of the assessment? So at any rate, this is exactly what I was pointing at earlier. This is an example of that assessment where we indicate, by the way, keep in mind, this was a very very rudimentary prototype to illustrate a concept and to illustrate what could be done. Clearly, from a UI standpoint, we could have done a lot more in terms of presenting the things that needed more attention or immediate attention in red, things that were just warning, we might have used maybe a yellow color, and things that were informational, we could have presented those in green. So there's a lot more that could have been done. We just wanted to convey the information or convey the fact that we don't need to send all that information to the cloud. We could actually move the processing closer to the edge and then make an assessment and then only communicate what is actually necessary or what needs to be done as a result of that assessment. So that's the end of my presentation. I was actually surprised that I could cover all that in the time that I did. This is actually a list of, is our call to action, if you will. So in our experience, try to determine the relevant conditions and constraints of the project environment. As I tried to do, in your research, in your exposure to the different elements, use the best criteria possible for your particular use case, for your particular set of circumstances as an organization that may be developing a solution. Look at what are the different constraints you need to address. Look at the community that's behind the project. And reach out to them. What I actually found out was that if I were to decide just on my experience with the level of support of the community, it would have been impossible for me to actually decide on one particular offering. Because when I started looking at these projects, I actually reached out to different people from the different foundations, from the different projects. And at all times, I sensed that there was an element, a very strong element of collaboration and a very strong element of wanting to help, of actually contributing and collaborating. And that was actually very encouraging to me. Another suggestion that I have for you is if you have an opportunity, read that State of the Edge report. There's a link to it on this slide. It is actually a very comprehensive document. It's actually like 99 pages, if I remember correctly. There's a lot of great information there. Lots of different viewpoints, which is something that I also found very useful, because sometimes it's hard to get out of your mindset as a developer. Sometimes you develop, this tunnel vision, and sometimes being exposed to a different point of view turns out to be extremely helpful. Another call to action, try to get that other paper from the Linux Foundation, Sharpening the Edge, where they talk about the edge taxonomy and how you can move the edge through that continuum from the data center to the edge or the extreme edge, and what that entails. And that was probably the biggest value that I extracted out of that paper. And finally, if we can be of any help to you, please connect with us, send us an email. We're available at info@datacrunchlab.com. And with that, thank you very much. I invite you to connect with me on LinkedIn. And if you want a copy of the charts, send us an email to info@datacrunchlab.com.